Hey everyone, welcome back to another video of mine where today we're going to be solving Leetcode problem 70 titled Climbing Stairs. So we're climbing a staircase, right, and it takes n steps to actually reach the top of the staircase to basically meet our end goal, right? And each time we have a choice. We can either climb one step or two steps. And we simply need to output the number of distinct ways we can actually climb to the top of the staircase, or basically n steps up, right? So honestly, this should have been a medium problem at least, and it probably would have been if there wasn't a very simple, very nice pattern embedded within this problem. And you guys will see what that pattern is in a few seconds. Right, so in example 1, we have an input of n equal to 2, basically meaning that we have to take 2 steps to reach the top, and our output would be 2 because there's exactly 2 distinct ways to actually climb up 2 steps, considering we only are limited to climbing only 1 or either 2 steps at a time. Right, and the 2 distinct ways of climbing 2 steps up is either 1 step plus 1 step, taking 2 turns, or just directly climbing 2 steps at one go at once. Right, and if we apply that same logic to examples 2, we will see that for n equals 3, we'll have an output of 3 because there's 3 different ways to climb to the top, either starting 1, 1, 1, or starting with 1, ending with 2, or starting with 2 and ending with 1. So the very important pattern here is going to be that this is basically the Fibonacci sequence, and when it asks how many distinct ways we can actually climb to the top. And you may be wondering, how in the world is this a Fibonacci sequence, right? You may recognize, okay, I have 1 and I have 2, which is basically the indices that you're summing up with the Fibonacci sequence, so that's kind of similar. But how does this even resemble a Fibonacci sequence? And let me tell you how, right? We know that when we want to find the number of distinct ways to get to 1/nth indice or 1/nth input number, that's basically going to be how many distinct ways we can go from n minus 1 plus n minus 2, because we can either go from 1 step at a time or 2 steps at a time, right? Basically meaning that if n is 3, the number of distinct ways we can go 3 steps is basically going to be the number of distinct ways we can go 2 steps at a time and 1 step at a time, right? Basically, the number of distinct ways we can reach the top when n is equals 2 or when n equals 1. Basically, 3 minus 2 and 3 minus 1. And basically, that's saying that n, when basically n is the input, or basically the number of steps we need to reach the top, is basically going to be equal to f at n minus 1 plus f at n minus 2, right? Which is literally the definition of the Fibonacci sequence, right? And I'll give you an example. Let's say f in this case was 3. The number of distinct ways we can actually climb 3 steps to the top, given the limitations that we can either climb 1 or 2 steps, is basically going to be f at 2 plus f at 1, right? Basically, the number of distinct ways we can climb when n equals 2 plus the number of distinct ways we can climb when n equals 1. And we can basically keep updating these f inputs as we build up our range and while we iterate within the n input value. Okay? And we'll initialize our variables like this. What I'll do is I'll have a first variable and I'll have a second variable equal to, okay, looks like I really can't spell, equal to both 1. Right, so the first variable is essentially just going to say how many different ways we can climb when n equals 1. And the second variable, it may be seeming very counterintuitive. You might say, hey, the second variable should really denote how many times we can climb when n equals 2. So why is this set equal to 1? The reality is, the best explanation that I have for you is, if n equals 3, and once we start iterating from when n equals 3 in our loop, it will actually fix itself, right? The code will actually just adjust itself. And you guys will see how, right? So we'll loop through n, right? So we'll say, for I in the range of n minus 1. And you may be thinking again, hey, this seems counterintuitive. Why are we looping till n minus 1 exclusive? So basically n minus 2 inclusive, right? What happened to the last 2 elements, or the last 3 elements? Right? And the reason why we don't include those values is because we already have 2 elements starting for when n equals 1 or 2. So we don't want to overcount and go above the n value, but we want to stay within the range of the n value. So basically we can just dynamically update our variables until that nth value, or the nth Fibonacci number, which basically tells us how many distinct ways we can climb to the top, right? And if we go till n, or n plus 1 exclusive, this is going to overcount because we already have 2 variables initialized for 2 of the f of n's, right? So we'll do n minus 1 to avoid overcounting, right? So we'll say for I in the range of n minus 1, and now we'll say our temporary, in fact, I'll do this later. We'll say our first variable, as we talked about before, is going to be the first variable plus the second variable, right? Basically, f of n is going to be f of n plus f of n minus 1, right? So we're updating this variable as we loop through all the values within the nth range. And now we actually have to update our second variable, right? Our second variable also has to catch up to our first variable. So we'll say second is going to be equal to first. But there is an issue in this code. We will already have updated our first variable before we actually reset our second variable to that original first variable value. And so what we'll do is we'll get a temporary variable and set that equal to our first variable. So we can just have that first original value of our first variable stored somewhere that we can reaccess and give it that value back to our second variable, right? And at this point, we will have dynamically appended and updated our first variable to it for it to match f of n, or basically how many distinct ways we can climb up to the top when n is a specific value, or basically the sum of n minus 1, f of n minus 1 and f of n minus 2, as basically defined by the Fibonacci sequence, right? And so at this point we can simply return 1. And if I were to submit this, unless I made any syntax errors here, this should be completely fine. Okay, let's see. Okay, yeah, this should be returned first. Sorry, I used the variable 1 instead of first when I solved this problem a while back, and so that's why. Okay, let's see what I did wrong here. Find the range of 1, 1, temp is equal to first is equal to first plus second. Okay, sorry, this should be temp. That's my bad, right? And the reason why that second should actually be equal to temp is because when we actually have temp, we're actually updating that before we actually set it equal to second. And so our second would be in the wrong place value, and it instead would be equal to first plus second and be equal to first rather than equal to the original value of first, right? And as you can see, this is just about as efficient you can get of a dynamic programming solution. We beat 67% of users runtime-wise, and memory-wise, we beat 90% of users. And basically, that's because we're not actually really using any extra data structures to store any memory and allocate any memory for any elements based on our input. And so we're going to have, actually, as you can see, a constant time, or O of 1, memory times space complexity. And runtime wise, of course, is going to be O of n, because we're looping through till the nth value, or in this case, n minus 2 inclusive. Right, so to kind of just recap what this code is really doing, we have a first and second variable symbolizing how much time it takes, or basically the variable initializers for the first two n possible values in our Fibonacci sequence, right? And second being equal to 1 may seem counterintuitive, as you may think it equal to 2, but it will actually adjust itself from once n actually hits 3, and so on and so forth as you loop through till you actually hit that n minus 2th value. Right, so we loop through for I in the range n minus 1, basically skipping the first initial values because we already have them accounted for in the first and second variables, and we don't want to overcount and go above that nth value to get any extra distinct ways we can climb to the top based on the nth input value. Right, we set a temporary variable equal to the original value of the first variable, just so we can reset it back to the second variable as we update it after we dynamically update our first variable to be the first plus second, as denoted by the Fibonacci sequence, right? Where f of n is going to be equal to f of n minus 1 plus f of n minus 2, right? And yet, at the end of the day, at first we'll essentially have representing the number of distinct ways, or basically f of n minus 1 plus f of n minus 2 when we have n as the input, and we can simply return first, right? And that's going to have the number of distinct ways we can climb up to the top when we have n steps, right? And let's take an example here. Let's say n was actually 3, right? The simple problem, as we know in example 2, we know that our output should be 3 when n equals 3, but let's actually run through this code to see what would happen when n equals 3. So regardless of what n is, of course, we'll still have these two variables set equal to 1, and we'll loop through for I in the range of n minus 1, right? So this is basically saying for I in the range of 3 minus 1. Okay, and this 3 minus 1 is going to be exclusive. So instead of being for I in the range 2, it's going to be for I in the range 1. And of course, when you range or loop through iterators in Python, it's going to start from 0. Alright, so we'll just have basically one iteration. We'll have temp to be the first. So basically, we'll say temp is going to be equal to 1, which is basically set equal to the first variable, as we saw on line 3. And we'll have our first to be equal to the first plus second, which in this case is going to be 1 plus 1, or in other words, 2. And we'll have second to actually be temp. So we'll say second is actually going to be equal to 1, right? And now we've finished the 0th iteration, and we're going to go to the first iteration, right? Basically the final iteration for this loop, since n is only 3. And now we'll say temp is going to be equal to first. So in this case, temp is going to be reset to 2. And first is going to be reset to first plus second, which in this case is going to be 2 plus 1, which is going to be 3. And our second is going to be reset to 2, right? Basically our temp value. And now we're done with the iteration. We've iterated through the values 0 and 1 as denoted by our for loop on line 4, and we can simply return the first, which in this case is going to be equal to 3, as we saw in example 2, where when our input n is going to be equal to 3, our output is going to be 3 as well. So this is probably the most simple and core concept for dynamic programming, and it's honestly a very good starting problem for dynamic programming, just to get your hands dirty on how it actually works, and of course the basics and core concepts of the Fibonacci sequence. And like I said at the beginning of this video, if you actually don't realize that this is basically the Fibonacci sequence, where f at n is basically the number of distinct values at f of n minus 1 and f of n minus 2, this problem does get very hard, and it isn't very intuitive if you don't use that Fibonacci sequence pattern, right? So if you guys enjoyed this solution and learned something new, please make sure to like this video and subscribe to my channel. It really does mean a lot, and it really does motivate me to keep uploading and keep teaching you guys how to code and how to solve these algorithmic and data structure type problems. And of course, it is very beneficial for your problem solving skills as well. So I hope you guys enjoyed this video, learned something new, and I'll see you guys in the next video. Bye bye.